So continuing in this video with working with the data from the previous example, which was looking at the repair times for Verizon based on their two groups of customers, the ILEC, which are their own customers, and the CLEC, which are the customers of their competitors in that region. And what we wanted to see was, are the repair times for Verizon's own customers, ILEC, about the same as the CLEC? And rather than look at the difference in these two means, we're going to look at the ratio so we can see how many times longer the CLEC customers wait than ILEC customers. So you can check the code. All of this code is in Verizon mean ratio.r, but we'll look at this as like a fill in the blank sort of question. So maybe on an exam, I might ask you this and have blanks where all of these red boxes are and ask you what would you fill in the red box to complete the code. So you might want to hit pause and try this out on your own, and then listen to the explanation, and then open that Verizon file and see if you're able to understand the code in there. So what's not listed here is the first thing that you would need to do is load the library resample data. And then on the previous slide, we subset the data by group. So this first line is just going to split off the data so that we have all of the Verizon times just for the ILEC customers. And this contains 1,664 observations. And then we can look at the CLEC customers, and that one contained much less. There were 23 customers in that data set. And we're going to create 10 to the fourth, so in other words, 10,000 Bootstrap resamples from this data set. And what we're going to calculate is going to be the ratio of the two means. So for each of the 10,000 resamples that I create, what I'm going to do is calculate the mean of the ILEC resample divided by the mean of the CLEC sample. We're going to store it in this variable and then repeat. So that's what this for loop is telling us over here. So I'm going to do this 10,000 times. And I'm going to create a group called ILEC sample. So this is going to be our Bootstrap sample that we create from the time ILEC group. So in other words, what we're going to do is sample from the time.ilec groups. And what goes in this box and in over here and this box over here, well, we need to tell R how many values we're going to pick for this sample. And so here we should pick 1,664. So this should be the same size as the original sample that we started with. So we can clear that out. And if you didn't have these counts, then what's a nice way to do it is to use this length function in R, which is going to tell you how many values are in time ILEC. So here you could just type in the number 1,664, but if you didn't count that separately, then you can just input length function, which is going to do that count for you. And of course, when we're bootstrapping, we always want to do this with replacement. So we're going to use the true option on replace. So this is going to pick a value from our time ILEC group. Then it's going to put it back and pick another one, and it's going to repeat this 1,664 times. So that creates one Bootstrap sample for the ILEC group. And then for the CLEC group, it's the same story. Over here, what are we going to enter in? We're going to enter the length for the time.clec, and what I'm missing here is there should be a parenthesis right there. And again, we're going to use the replace equals true option for that. So now we've got our two Bootstrap resamples. And before we create a new one, what we want to do is then take the mean of the ILEC sample and divide that by the mean of the CLEC sample. And that is what we have over here. So we're taking the mean ILEC.sample and we're dividing by the mean of CLEC sample. So on top are their customer mean times On the bottom are their competitor, are the repair times that they had for their when they made repairs for their competitors. And so after executing that for loop, we've got 10,000 Bootstrap samples, and then we can take a look at the distribution of all of these Bootstrap ratios. But this question was saying, let's construct a 95% Bootstrap confidence interval for this ratio. So the thing that we can use to pull off those upper and lower cutoffs for our confidence interval are the quantiles. And so here, if we have our Bootstrap distribution and we want the middle 95%, then that means we're missing 5% of the data on the two tails that we split up evenly. So that would be the 0.025 quantile, and then over here would be the 0.975 quantile. So in that sense, each of our tails, the lower and the upper tail, have an area of 0.025 in it. So that's how we determine those cutoffs. So we're going to take a look at all of the time ratio data. So we're going to pull in all of those means that we just calculated, all of those ratios that we just calculated, and then we're going to choose our cutoffs for the 95% confidence interval. And just recall, we've looked at other percentiles. So if we did a different confidence level, 90% or 99%, then we would need to adjust these cutoffs accordingly. So our original ratio, which we calculated on the previous slide, we could calculate by taking the mean of all of the original sample for the ILEC times and divide that by the mean for the repair times for the CLEC customers. And that came out to be a little bit more than 1/2. And then what I can do is calculate the mean of all of my Bootstrap resamples. So in other words, this is going to tell us where is the center of our Bootstrap distribution. And so for that, rather than use the original values, we're going to pull in and calculate the mean of time ratio dot mean. And if I wanted to take a look at this picture that I sketched on the margins over here more accurately, then we could create a histogram for the time.ratio.mean data. So those were the ratios of each of our Bootstrap resamples. And these lines that we're going to draw in on top of our histogram, these are going to denote what the original sample was. That's what we have down here. And this is going to be the center of the Bootstrap. So here's our original sample, and this is the center of the Bootstrap distribution. And way down on the bottom, we could also calculate and compare the distribution that we get, the shape of the distribution, to a normal distribution. So we can see if the distribution of the Bootstrap of a ratio of two means is normal, like the difference of two means was. So QQ norm is going to say we're going to create a QQ plot comparing the standard normal distribution to whatever you tell me to compare it to inside here. And our Bootstrap distribution is time.ratio.mean. And the QQ line is going to give us some reference of figuring out how normal or unnormal our data looks compared to the standard normal distribution. So here we would also just input time.ratio.mean. And so we really haven't changed much in our process here other than what is the statistic that we're looking at. And so instead of the difference in these two means, we're now looking at the ratio of these two means. But otherwise, we really haven't made any other changes. And please do check out the file Verizon mean ratio in Canvas to play around with the code. So on the next slide, we'll take a look at the output that we get from this code.